Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. All right, everyone. I am on the line with Ahmed Elgammal. Ahmed is a professor in the Department of Computer Science at Rutgers University, as well as director of the Art and Artificial Intelligence Lab there. Ahmed, welcome to This Week in Machine Learning and AI.
Thank you for inviting me.
Absolutely. I'd like to get started by having you share a little bit about your background and what brought you to an interest in kind of the space of digital humanities and this confluence of art and AI, and more broadly, your interests in computer vision.
Yes. So my career has been around artificial intelligence for a long time, in particular computer vision. I'm a computer vision person, but also have a long passion for art for a long time. And as a computer vision person, I always find it very interesting that we in computer vision look at images and can recognize cars and dogs and cats and man and woman, things like that. But obviously, if you look at an artwork, that's not what we're looking for. It's much deeper. There are layers and layers of understanding of artworks that we do as human when you look at artworks, and also not only the understanding, but artwork affects us at the emotional level. So it's much deeper than just what we do in computer science and computer vision. That always intrigues me, and that as an AI person, I always find it very interesting and very fascinating. Because I really believe that AI is not only about driving a car or playing chess in order to have a machine that is intelligent at the level of human intelligence. The machine has to be able to understand these creative products like art and music and literature and jokes, and not only understand them, but be able to create them as well. And this is not something new, actually. Since the beginning of AI, since the dawn of AI, scientists has been trying to do that. Have been trying to create art and create music and understand art and music. However, it has been very challenging, and I believe this is one of the important aspects to prove that AI is actually intelligent.
One of your recent projects is a tool called AICAN, which is focused on generating art. Can you talk a little bit about the genesis of that project and ultimately the capabilities of that tool?
Yes. So in AI, in the last few years, GAN came around, Generative Adversarial Network, which is an amazing tool to generate images, in particular, given some training sets. So GAN, by design, is supposed to generate new samples of some distribution. So if you give it images of cats, it will try to generate more and more images of cats. And some people have tried to use GANs before to make artworks, like you give it portraits, Renaissance portraits, for example, and try to generate these portraits. However, our understanding of art is very different. I believe that art is about innovation and making something novel. So if you just generate samples from the same distribution of art that you give it, it's not going to be art. It's not going to be called art. That's imitation of art. So you have to be creative. You have to push the machine to be creative. There's a whole field of subfield of AI called computational creativity, where scientists in that field has been for a long time studying how to make the machine creative, how to make a creative process, whether you are creating music or artwork, visual art or literature or jokes or anything like that. So my goal is really was how can we change GANs to make it creative, not just simulating distribution, but pushing the envelope of art to make something new. And then our long study of these issues in the lab helped us into formulating this problem. So first, we have to come up with a theory about how art evolved to start with, how artists make new art. Obviously, these are theories, or there are several theories about that. The theory we used is coming from psychology by a scientist. His name is Colin Martindale. Here's the question: like, if you look at history of art, what happened? I mean, why artists keep evolving the styles as they go? Like why Baroque happened after Renaissance, and why Impressionism happened in 19th century, and why Cubism came after that? And is it just random, or there is something fundamental in how these styles emerge and evolve? So basically, artist always has to generate new ideas in their art to push against what's called habituation. Because if you keep looking at the same art for a long time, it's not interesting for you anymore as an artist, as a viewer. So artist has to always innovate. However, this innovation has to come with what's called least effort, because if you innovate too much in your art, it's unlikely that people will accept that. Will be too shocking for people. So arts has to innovate to a certain degree, but with a limited amount of innovation, somehow to push against habituation, according to the least effort principle. So that's exactly what we're trying to implement to make GANs creative. So we developed what's called a creative adversarial network. It's a variant of GAN that's really designed to be implementing this concept. So how can we make it innovative or push the novelty? There are different ways to do that. In particular, we looked at what's called style ambiguity, which is a process that simulates how artists break out of style. So suppose, for example, you are an impressionist artist living in the 19th century, making a lot of impressionist work. After a while, you have exerted all possible things you could do within that style. You have painted all possible facades, all possible landscapes, all possible scenes in that style. And at some time, you have to you already exerted all these possibilities. If you are a new artist, even if you like that style and you innovate, there is no room for innovation anymore within the style. So that's basically the reason why most artists at a certain point break out of style and try to create something new, coming up with something new. Like, for example, Cezanne at the time, or Van Gogh at that time, trying to break out of Impressionism and do what was called after that post-Impressionism. So that's exactly what we're trying to do here. How can we digest what happened in art history to certain points, until certain points, and break out of style to create something new?
Can I jump into with a question? And this may lead you into what you actually did, but when I think about what you're proposing, that we develop a model of the way art is generated, and in this case, the model kind of supposes that the artist lives within some style, but there are maybe kind of random pushes of the envelope, if you will. Or maybe they're not random, but an individual artist innovates, but not too much. I kind of get that as a simplistic model for the evolution of art, but it does seem like coming up with some kind of representation for that and how that happens would be very complex computationally.
Yes, definitely. You have to simplify it. Yes, and that's what we managed to do, at least to a certain degree. We suppose you give the machine lots and lots of images of art. What we did was we give it art from the last 500 years of Western canon of art history. And we only gave the machine the artworks and the style of each artwork, according to styles from art historian like Renaissance, Baroque, Impressionism, Realism, all these art movement that happened. So this is the only thing that the machine gives the machine: the art, the images of the art, and these labels. So the formulation here is that we want the generator. We want to put the generator under two opposing forces. in one hand, like a typical GAN, it need to learn the distribution of art, try to generate something from that distribution. But that would be only imitation, right? So how can you push it to be innovative? So we added what we call style ambiguity. We want to basically the generator generate something that follows the distribution, but doesn't follow existing styles at all. So in order to do that, the discriminator here has to be equipped with a style classifier. So the discriminator has to be able to tell for any new artwork what style is it. Is it Renaissance? Is it Baroque? Is it Cubism? Is it abstract? So the generator job here is to find out a solution that generate images, follow the general aesthetics of art, follow the same distribution of art, but in the same time doesn't follow any existing styles, because if it generated another impressionist art or another cubism art, it's going to get penalized. So you see the dilemma here. So it has to generate something that fits the aesthetics in general, but doesn't fit existing styles. And that what needed to innovate in a style, but follow the aesthetics, doesn't really make something shockingly random that people won't accept. And we see that right away in the generation. What it generates is always following the style, following the aesthetics. So you can see good choice of colors, a good choice of compositional rules, a variety of texture. But at the same time, you cannot easily put what it generates into any existing style. It doesn't repeat what happened before. We don't see anything that looks like Renaissance portrait or Impressionist art or Cubism art. We can always see that it innovates and try to make something new out of that. So these two forces actually kind of push the innovation, but limit the innovation at the same time, because we pull it back to the distribution of art, so it doesn't go astray and try to start generating random things that's going to be too innovative.
How do you kind of enforce this rule to maintain the aesthetic but not the style within the GAN?
Basically, the loss function of the GAN, we change the loss function of the GAN such that it has these two opposing losses. In one hand, it has the typical GAN loss, which is try to generate images from distribution, the real fake loss as usual in a GAN setting. So it is that's the incentive to be within the aesthetics. But in the same time, we have the style ambiguity loss, which is basically based on the style classifier of the discriminator. We compute some sort of entropy score out of that style classifier, and we basically try to maximize this style ambiguity. So in one hand, we want to minimize the diversion from the distribution of art, but at the same time, we want to maximize the ambiguity of the style. So this implemented the two opposing forces.
Okay, and now is the loss function, when it's evaluated, is that a scalar? And I guess what I'm asking is, like, do you have this issue where you have these two opposing components of your loss function that just average out and kind of you lose all of the information and the nuance in the two different components, or is that not an issue here?
That's exactly what it's trying to do. I mean, it tries to find out a part of in the surface of the optimization that you are doing that in between the two. You want to minimize one, maximize the other. So it has to find some sweet spot between the two.
I'm curious about the training process. You've got how many images did you train the GAN on?
Yeah, the first version we did, it was about 80,000 images from last 500 years of Western art, about 20 different styles that we reused, starting from Renaissance to all the way to contemporary art. Almost uniform among all the styles, make sure that we don't have any bias in the data. So roughly all the styles are uniform in number. So the interesting thing was that under these constraints, we find that the machine tends to generate more and more abstract works of art, less figurative artworks, and more abstract works of art, which is very interesting. Why is that? I mean, why favor to generate abstract artworks and not figurative artwork? For the we kept thinking about that for a long time. So why is that? But when we look at the progression of history of art, one thing we find interesting in the results is that the machine, under these constraints that we put in, generates more and more abstract artworks and less figurative. We hardly see any portraits or any landscape generated. It's more about more abstract and more it's a little bit surrealist nature. So we were wondering why is that? Why the machine generates more abstract? However, if you look at art history and look at the progression art history, and this is some other research we have done also, we actually find that it's clear that art history moves into a trajectory from figurative art through the history in the last 5 centuries until we reach the 20th century, where artists move into abstraction and very pure abstraction, and then later into color field painting and abstract expressionism and till contemporary art. So there is a clear trajectory of art moving away from figurative art into abstraction, which basically it seems that the machine here figured out that there's this trajectory, and in order to create novel art, it has to be more into the abstract realm of art. So under this constraint that we put into the formulation, it seemed that finding a good solution, abstract art provide a good solution that fits these two constraints. Because if you start generating figurative art, it's probably going to generate things that looks like Renaissance or Baroque or other classical styles, so it gets banalized. While for abstract art, I think there's a lot of room for experiment the machine or results the machine can generate that doesn't really fit into existing styles that easy. So it seems that's why the machine is generating more and more of these abstract works.
The website is AICAN.io, and we'll put a link in the show notes. I definitely, the abstract nature of the results are very apparent. When I think about kind of the, art that might be generated by a GAN, what comes to mind is more like if you remember back in 2012, this woman tried to do a hand restoration of this Spanish fresco, Ecce Homo, and basically made it look really, really bad. And that's kind of what I think of when you kind of think of GAN-generated images. At least, the GANs are getting a lot better now. But these are decidedly abstract. And in fact, you have a gallery on the site that's kind of the 2017 version of ICAN, and then a 2018 version of ICAN, and just kind of comparing the two visually. And I'd like you to comment on, whether, this could be kind of selection bias. You handpicked, the images kind of differently or something, but the art is much better in the gallery that you're displaying for 2018. Is that characteristic of the second version of the model's results, or did you just pick better art for the website?
No, just basically we train it more and more data for longer time, and it perfecting the process. So that's why it's getting better.
That's maybe not, not intuitive. That I would almost expect maybe that a counterintuitive result or the opposite result. You train it, with more. If you're training it with more historical art, that it would tend more towards kind of reproducing what it sees than to get further out into abstraction, if that makes any sense.
No, that's absolutely not. That's the whole idea. That AICAN would do that. AICAN would definitely try, if you get more data and more training, it will emulate the data better.
Yeah.
But what we're doing here is the variant that we drive, which is creative adversarial network, which is by definition, it doesn't try to generate anything that existed before, because if it generates things that stimulate what existed before, that get penalized because of the style ambiguity part of the loss.
Mm-hmm.
So it has to generate something that doesn't fit existing style at all,
Mm-hmm.
but follows the aesthetics. That's why it's always has tried to generate things that are not falling into existing styles, and that's why it pushed the creativity of the result. So having more data will not make it emulate the results by definition, because we still have to innovate according to the laws. And actually, let me discuss this according to your question. Why this is different from GAN's generated images of art? Exactly. If you look at most of art generated by using GANs, especially maybe a year or 2 years old, I mean, now GAN's getting better. If you give it portraits, for example, as training sets, it will generate what looks like deformed portraits, right? So you can see kind of Francis Bacon deformed style of portraits in the generation. That's the
Mm-hmm.
typical GAN images that you see for several artists generating art using GANs are having this characteristic.
Mm-hmm.
So what happens in that case is actually the GANs are not successful in generating good portraits. So the GAN actually fails in generating the portraits correctly, and because of the deformation, that's why we will find it interesting. So it surprises you because of the deformation, and that surprise is why you might like it or might not like it as a viewer. That's why that's the main aesthetics in GAN generated images, the element of deformation or failure to imitate the training data. So, and that's exactly what we pointed out in our academic paper when we derived the CAN, is that we think of this failure to imitate the distribution as a failure case, not a creative process. The machine here is not intentionally deforming the image. The machine is just failing to imitate the portrait. For us as a viewer, it's an interesting thing to look at. But the process here is not creative. The process here is an emulative process that just failed, right?
Mm-hmm.
And that's totally not what we are trying to do. We're trying to really be constructive in being creative, meaning that the machine, in our case, when we do CAN, creative adversarial network, the machine from the beginning trying to generate something that have these two constraints put into place, follows the aesthetic but doesn't follow existing style. So with these two constraints, the machine has to find a solution that satisfies these two constraints. Art history, if you look at the way art history progressed over time, there is a quote from an art historian, his name is Heinrich Wolblin, who say that style has to evolve in a smooth way, like a rock rolling down a hill, meaning that first style doesn't jump. We cannot have Renaissance moving into Impressionism and moving back to Baroque and then moving to Realism. No, it doesn't happen this way. Style move in a very slowly over time, from Renaissance to Baroque to in a very ordered way. So if you push the machine to generate something that doesn't fit existing styles but fit the aesthetics, it cannot find a solution by mixing out, for example, Renaissance and Baroque, or mixing out Baroque and Impressionism, or try to find something in between. There is no way to find something in between solution. So the only way for the machine to solve this problem is really to extrapolate on that trajectory, figure out that there is a trajectory of how art progressed, and then generate something on top of that. And that's why generate more and more abstract works. So by construction here, is the machine has a creative process in terms of generating the art. It doesn't emulate; it has to always innovate. And the source of aesthetics of what you see is this creative process. Is not the failure to generate something from the data set. It's not the failure to generate a portrait. It's not a failure to generate a landscape. The real aesthetics here coming from the fact that it follows the aesthetic rules, it learns the aesthetic rules, but try to constructively generating something new.
Yeah, I'm not sure I fully understand that. So what I hear you saying is you've got this, the history of art is this progression or sequence of styles, and what your CAN kind of creative adversarial network is creating is something that is art that doesn't exist kind of between two styles, but kind of by definition uh, projects out from kind of the last element of that sequence. And maybe you're just speaking figuratively, and I'm trying to be too literal or rigorous about this. But why is that necessarily the case? Why is it that the things that we're seeing are not kind of orthogonal to the sequence of styles that we've seen?
Yeah, it's a good question. Yes, it can. It can be. Because at the end, I mean, the machine tries to find a solution given the constraint we give it. But let me point you out to another piece of research that we have done. In another research, we looked at what representation the machine learns if we teach it to classify styles. So we give the machine lots of images and style labels and train lots of neural networks to classify styles, just to try and classify whether the art is Renaissance, Baroque, Impressionism, and so on, just style classification. Mm-hmm. But then what we looked at what representation the machine learned. So we look at the activation of the fully connected layers in this network, and look at the things like the principal component analysis of these activations and the manifold of activation and things like that. And to our surprise, when you look at this, we find that the machine arranged the data in a chronological order by itself.
Interesting.
So yeah, we never give the machine anything about the date of the artwork, or that Renaissance happened before Baroque, or Baroque happened before Cubism or Impressionism. We found that when you look at two-dimension plot of the data, Renaissance come first, followed by Baroque, followed by 17th century, 18th century art, and then comes 19th century art, realism and Impressionism, and then move to Cezanne and move to Cubism and abstract by itself. It's amazing. I mean, you can find that the machine, the art has evolved into a full circle, going from Renaissance all the way to 20th century in a very smooth way, and the machine discovered that by itself.
Interesting. I was going to ask what happens if you tell the network kind of the sequence by feeding in dates, but it sounds like you don't have to. It figures it out.
Exactly. And that exactly explains why the machine actually generated art that is more non-figurative and more abstract at the end.
Can you elaborate a little bit on how you got to this two-dimensional or kind of time representation or sequential representation from the activations?
So basically we look at the activation space and look at the modes of variation, the principal component analysis of this activation space. And what we find that first, you can explain almost 95% of the variance of the data using very few number of components in the activation space, usually 5-6 components in all the networks that you have seen. And actually, the first two dimensions, the first two modes of variation captured about 70% of the variance. And if you plot the data against these two modes of variation, you can always clearly see this progression, chronological progression from 14th century till now, where if you go radially across, clockwise across that two-dimension plot, it has about 70% correlation with time. So the machine figured out this smooth transition by itself, which basically tell us that the one thing we already know from art history is that style progress in a very smooth way. It doesn't progress in a random way. It progressed in a very smooth way. And that's what the machine would figure out by itself.
If I were to create a model for the evolution of art, being someone who's probably as far as you can get from someone who knows anything about this, but I would kind of evolve the model that you've described, where you've got these, these kind of styles and then these perturbations in aesthetic or perturbations in, how did you describe that earlier? The kind of the simple model for the way art evolves?
You want to push innovation, and there are multiple ways to push innovation, but you want to push innovation in a least amount or least with least effort.
Right. So you've got this, this kind of style that has evolved, and you kind of innovate in these small incremental ways. And I guess what's missing for that for me is it strikes me that you have a lot of that, and then you have these kind of big step function innovations that are much more dramatic than the small random innovations. Is that just not true from, the kind of research into the evolution of art, or is that a possible, further extension of work like this to incorporate that type of model?
Actually, what you're saying is true. There are different ways artists innovate in their work. They can innovate within the style, and they can break out of style. And this is something that Martin Dale actually pointed out. Most artists work within a style, meaning that there is a predominant style at any time in history. And most artists just work within that style. Like if you are in 17th century, probably you are going to do Baroque. That's what's happening, and everybody is doing within the rules of Baroque style. But what happened is at certain points, artists really are get bored of these rules that they are working with, because they tried all possible subject matter within that style, and there is no room for innovation anymore. When you're working within the style, the only way you innovate is to look at different subject matter within the style. You try a different story, different scene, different things, but everything within the style rules. But at certain points, you exerted all these possibilities, and then that's where really important artists come up with new break out of the style. That's what happened, for example, when Picasso break out of what's happened and painted Ladies of Avignon, for example, in 1907. And that was too innovative at its time. It led to the beginning of Cubism, or earlier when Munch painted the Scream and early works of Expressionism. So there are always certain artists who break out of style, and other artists start to copy these new styles and follow their direction. And that's the kind of innovation we plugged into the formulation of CAN, which is style ambiguity. We don't want the machine to generate something that fits existing style, because if it generates something that fits existing style, the entropy, there will be no surprise. The entropy will be very low for that part of the loss, and we're trying to maximize that part. So the machine has to always generate something that the classifier, the discriminator, cannot classify, be almost uniform in terms of classifying that style according to the style that you give the machine. So that's where the style ambiguity get maximized.
Okay, interesting. So I'm curious. This work in creativity is kind of one area of interest of yours. Were there any principles or observations that you made in working on this project that kind of informed your broader work in computer vision?
I have been focused more and more into that area in the last maybe 6-7 years, trying to really understand more how to make the machine understand art, and so generation of art is something that came actually out of long progress into understanding these concepts. So the earlier work that we have done in that area was things like how to classify styles, how to classify the genre of art, how to classify artists, how to look at artistic influences, and even we have works earlier on how to quantify creativity in artwork. Like, can you look at art history and look at images only and their time stamps and find out artworks that were creative in their time. And actually, we find that the machine, by some formulation related to what's called network centrality, could figure out important pieces of art through art history just by looking at images of art and their dates, without knowing anything else about styles or about about artists or anything like that. So the machine figure out, for example, things like Picasso's Ladies Avignon or Munch's Scream or Monet Haystack as fundamental, important pieces of artwork in history. And that led us actually to formulating the creative adversarial network as a variant of GAN that has this built-in process of style ambiguity as a constraint that help pushing the machine to be creative and innovative.
Interesting. So really, really interesting work. How do you see this this work evolving? What's next?
What's next is really we are focused now on how to. What we proved is basically that we can give the machine all this art history without any curation, just give it all art history, and it can generate almost autonomously new artworks. That's what we achieved. So that's a proof of concept that the machine can produce things autonomously to some degree. But what we really want to do is to give artists a control over the process. How can an artist control this generation to achieve something that you want to do, not just make it autonomous? And that's really what we try to do now, how to make it more collaborative and more controllable.
Fantastic. Well, Ahmed, thank you so much for taking the time to chat with us about your work.
Thank you very much.
All right, everyone, that's our show for today. If you like what you've heard here, please do us a huge favor and tell your friends about the show. And if you haven't already hit that subscribe button yourself, make sure you do so you don't miss any of the great episodes we've got in store for you. As always, thanks so much for listening, and catch you next time.